first one I hope is somewhat on the easy side for you. We have seen these very similar to before. So we're going to split it this way. So we have the square portion, which is the side squared, or side times side. So that's 100 feet squared, right? And then we have the rectangular portion, which is going to be 10 times 20. That's 200 feet squared. Do not forget to add these two together. So that's 300 feet squared. Also, you want to make sure that you're including the correct unit of measure, and since it's area, we will always have this 2 to indicate that we're looking for area. Alright, for this one it's a little tougher because we do have a triangle involved. A real world approach would be the side of a house or the front of the house where you're looking to cover it with paint or siding of some sort. So we'll go across this way. We'll do our easier one, which is the rectangular portion, so length times width, which is 48 centimeters squared. And then for a triangle, the formula, if you don't have the sheet in front of you, is half times the base times the height. Alright, so the half is going to stay. Our base in this case is actually 8. Okay, our height is right along here, right, is 4. So 8 times 4 is 32. We cut that in half. It's simply 16 centimeters squared. So we'll take this and add it together, so it's 64 centimeters squared. Alright, this particular shape is interesting, and I'll show you why in a minute. So we can see that we have a square right here, right, because we know that 12 and 12 are the same. 12 times 12 is 144 meters squared. And then on the bottom, which is our rectangular portion, we have the length and width, which is 6 times 24. Well, that's also 144 meters squared. So notice that the area is the same, but the way the layout of the room, if you're thinking of it like a blueprint, is different. We'll add those together, so you get 288 meters squared for that one. Okay, this particular one is interesting because since we're working with irregular composite figures, we would think that we could just simply go across, which you can, that will still work, and just dividing it into a triangle and a rectangle. But it's actually not necessary because if you look, this is actually a trapezoid on its side, right? And I'll just redraw it here to prove to you that it is. Alright, so if we relabel this, we have 2 for the top part, 4 for the height, and then 4 for the bottom. So I'm just kind of spinning it up on its side. So the formula for a trapezoid is half times the height times one of the bases plus the other base. So the one base, which is coming from here, will be added to the other base, which is coming from here. Remember, those are the parallel lines to one another. The height is also 4, which is this one, and then we're going to cut that whole thing in half when we're done. So 4 and 2 is 6. We multiply that by 4 when we're done, so we get 24, and we're going to take half of that, so it's actually 12 centimeters squared. Alright, this is a fun one, but let's first see where we're going to split it up. So we can see the rectangular portion, but let's go for that first. So that's 9 times 15. Well, 9 times 15 is 135 centimeters squared. Okay, now I want to pull out this rectangular, or I'm sorry, this triangular piece, right? I'll show you what numbers are involved for that. Okay, so we know that the height, this isn't the best drawing for a triangle, but we know that the height is 9, right? We're getting that from here. We're looking for the entire length or base across the bottom here. Well, that means we have to do some adding. Okay, so we're going to take 1.5, 1.5, which is 3, and then this 9 is again, so the base is 12. So we do base times height, cut it in half, right? That's the area for, the area for a triangle. So that's 108. We cut that in half, it's 54. So we take 54 and 135, that's 189 centimeters squared. Alright, here is another one, alright, that looks similar to something else we've done. So we're going to look at this and see that we could split it up right along here, but that's not what we're going to do. We can see that we can do this all in one shot, because once again, this is just a trapezoid. Alright, so let's relabel the pieces. So the bottom was 14, the larger portion. The height is also 14, and then the other base is 7. So you should have your formula sheet out. If you don't, we're going to do half times the height, which is this 14 right here. Right, the bases, which are the lines that are parallel to one another, are right here. Alright, so this is going to be pretty big. We could do this first. We could take half of 14, this part right here. Half of 14 is 7. The inside part, which we're going to actually add together, not multiply, 7 plus 14 is 21. We multiply that. 7 times 21 is 147. And once again, remember unit of measure, which is meters squared. Alright, here's another one that's similar to one we did before. Kind of looks like a house of some sort. We can clearly see that we can break it up right here. Right, the easier portion would be the 9 times the 26, which is your rectangular portion. I'm even going to use a calculator just to check. So 9 times, let's see, 9 times 26 equals 234. And then we do half times base, which in this case is 26, times the height, which is 17. Alright, we can simply throw that into the calculator, times 26 times 17. You should get 221. Alright, we're going to add those two together, which is 455 inches squared. Please remember your unit of measure. Teachers are going to mark that wrong. Alright, this is another fun one. So up to this point, we were breaking up our figures into two sections. In this case, we can actually break it into 3. Okay, a couple different ways you can go about it here. So let's go here, break it up right along here. Okay, so this is indicating that this entire piece is 15. Alright, so we're going to break it up like this. Like I said, this 15 is indicating that this entire piece is 15. Alright, from here to here only is 10. Okay, and then the entire thing along here is 30. We should establish that first. So now this is where it can get a little tough. So we know that from here to here is 8, okay, and here to here is 10. This is what I would do. Okay, we're going to look at it a little differently. Let's imagine that this goes all the way across, right? And we're looking at a full rectangle. Well, if that was the case, we would do 30 times the 15. That would be the area for this entire thing if we were shading it in. Now what we can do is take this portion and get rid of it. Well, what two numbers do you need? 8 and 10. 8 times 10 is 80. All right, we're not adding it. We're taking the shaded portion out because we're only looking for the area that's of this U, so to speak. So you subtract, it's 370 millimeters squared. Okay, that one was a little tough. Alright, and our last one, which will be our funnest one, is what we're going to do is we'll look at the rectangular portion first, which is simply 6 times 4, so that's 24. And then you'll notice that we have this semicircle. So remember, the 4 goes all the way across. Alright, and then the area of a circle is pi times radius squared. Okay, now if you look, that 4 is not the radius. That 4 is actually the diameter. So we want to cut that in half. Well, let's replace our pi. We're going to cut it in half, make it 2, and then square it. Which, ironically enough, you're probably not going to like me for this, brings us back to 4. Which will not always happen, but in this case it does. So we multiply that together, we get 12.56. Alright, we'll take that, add it to this. So our final answer, you would think, is 36.56. Alright, so if you were like, oh, this is easy, that's incorrect. So I was trying to trick you there a bit, but the reason that's incorrect, yes, we'll need the 24, but what is it that we have to do with the 12.56? Well, we got to cut it in half because there's only a semicircle. So 12.56 cut in half is then going to be 6.28. This is what we'll add with the 24, so our final answer is actually 30.28 centimeters squared. Okay, tough one because it's a semicircle, but you're going to see that definitely in real life. So, but even in our geometry, you see a lot of this.